Oh, beautiful for spacious skies, for ramble ways of grain, for purple mountains, majesties above the fruited plains. America, America, God shed his grace on thee and crown thy good with brotherhood. From sea to shining sea.
Removing the rivets on the clutch disc now. Now this is a two-sided clutch that rides inside the pulley system on Pearl, and I'm removing the rivets right now. Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and we're here in my shop. We're going back on Pearl. We're working on the clutch disc now, and I got some material in. I blasted up our components, and I actually took this plate and put it on my scanner, took a scan of it, put it in my 2D program, calculated out all the holes, cross-referenced it with the JPEG that I imported there, created a DFX file, put it through the WAM, and now I'm getting ready to position it where I want it on the machine, and then we're going to go ahead and cut it. Now let me take you and show you the clutch kind of cleaned up and what it looks like at this point. All right, everything I'm going to show you actually sits inside the pulley that comes up from the motor. Okay, so the pulley spins on its own bearings on the shaft behind the clutch, or the clutch goes inside. The pulley's hollowed out. The shaft that we've been working on that has the brake on the other end of it fits in here. It locks to the shaft with a set screw with a dog point through these 2 points right here. There's a square key here, and it actually fits into a bore, just like this one here that's been damaged. Okay, so I can braze this up and I can repair that, or I can go ahead and use this one right here. Whether that's going to throw it off balance or not, I don't know if it's that much. We are speeding up the lathe, so I have two areas that are damaged. This pinhole here and the one that mates it right here. It has a high spot right here, so that needs to be taken care of. We need to take that down. It looks like a little crack there, and see if I can get to. Okay, it's not the prettiest thing, but it's not 100%. I mean, I could just rotary burr this area out here and use this key and let it fly. But that's not me. All right, let's get back to the assembly here. I just wanted to, we're getting ready to do the brake disc, and that's what we want to play with today. So the collar goes over. This is the collar that keys into the inside of the pulley. So the pulley makes contact with this disc. So out here is connected to the pulley, and here is connected to the shaft. Okay, they spin freely from each other. This is the clamping plate, or the plate that actually pushes against the two of them and makes it grab. This is held in, not necessarily with this collar, but this collar screws on here in front of it. And I'm not going to get down to how far down it's going or anything else like that. This is the shifter that actually shifts between pulling the brake in, the brake cup that we've machined already for the inside. And when the brake cup is engaged, this actually pops out. And so it's actually out, and it's out just a little bit past center, otherwise it won't work. Okay, and then when so out a little bit, the brake's engaged, and then when you want to run the lathe, you want to engage the clutch, and you push this, pull this in, and it puts the finger pressure against this outside here when this is adjusted right. The tension is adjusted by a pull pin in here. So this goes around, and that's what all those pinholes are in there. That's what adjusts your tension on your brake disc. All right, so everything's sandblasted and cleaned up, and we're going to be doing some painting on these parts and some other things there. And the main thing is I wanted to get to the new clutch discs. We're going to do them out of 1/8 inch material. That's pretty close to what this is right here. This actually shows you two things. See this area up here? This is where it's joined. They formed, I don't know if they did it like a hot steam or whatever, but they formed the disc material. They probably only had strips, but they formed it in to where it came back up here and butted the joint, and then it actually has like a copper staple that they use to hold it together. And the rivets are just barely down below the surface, and 3 go one way, 3 go the other way, and the peen over of the rivet, in fact, actually you can see that one right there is still a little bit in there. I just punched it right on through there. All right, the other thing that you can see throughout this area right here, and it really showed up a lot when I sandblasted it, but it's metal impregnated disc material. That means it's high pressure, high friction rate disc material. Remember, the inside clutch discs we did out of medium grade material. It had no metal in it. All right, this is the extreme pressure, and this is impregnated with the bronze materials. This is my blank sheet right here that we're going to put in the wazer and water jet our shape. All right, and we're gonna cut, okay, close the door. This is a real fast project. 26.5 inches a minute. Estimated job time 4 minutes and 26 seconds for the complete job. Just under 1.5 pounds of abrasive is being used. The estimated cost for this project here for cutting these two pieces out is $1.16. Coming around the last outside circle on the second part right now. There we go. It's automatically draining the tank. I've learned a few things, so you can quickly rinse right now, and it'll drain the tank down until it gets to the sensor. Okay, let's go ahead and let's pop out our rings here. Pretty cool. We'll blow them off with the air, and we're going to go check them with our fit of our part that they're going to mate to. And you see the water's almost all drained down. There we go. All right, how cool is that? Pretty good. I had just a little minor chip out on this one little hole right here. But I think the results of the whole alignment right there and the spot base is going to be probably take most of that out of there, or I can put that side down. Now, I am going to epoxy these to the disc in addition to these rivets here, just because I believe that this clutch here, and I looked at the back side of the original and how it actually had a little bit of force on the rivets. Of course, who knows how long that clutch disc was in there. I was looking in, because there was another spot on this other one here as well. Some of the areas on the bed in there that I clamped to have been removed, or there wasn't support underneath on the bed. So laminating this with a piece of acrylic or something just to help spread the load of the part might actually keep it from blowing out that area. The pierce ins had a little bit of, the pierce in on the outside had a little deform, but the pierce on the inside is perfect. So I think it actually just has to do with having that support underneath this material here when jetting it. The holes are just unbelievably right on the money. In fact, I'm going to go get a rivet, and I'm actually going to see how close they were to the size and the alignment. And then we're gonna continue on our clutch job here. We need to, probably tomorrow, I'll probably get in here, and if I'm gonna braze repair, I'm gonna braze repair and then paint these items here so we can get going. The shift forks inside the gearbox, I got to start getting those. So in the next video, we're going to be starting to get some of the other areas taken care of inside the gearbox, including the second. We're working the primary shaft or the power shaft. We did the intermediate, short intermediate. We're going to do the long intermediate. We need to get that started and cleaned up. Last week I did a 3/8 bronze disc. Just cut out a disc because I needed to make a flange on a cutlass bearing. And here's a glimpse of that cut in the water jet. All right, this is the closest I've ever come to actually fitting a whole piece of material, or the part on a whole piece of material. This is like 4 1/4, and the circle is going to be 4 200, and we're just doing a dry run here. And I'm eyeballing it from the side to catch that back there. That looks pretty close to being right in the center, and that looks pretty close to being on the center. We might be just barely hitting here, and we might be outside there a little bit, but it's going to be close enough because the outside will turn down to 4" on the finished part there. Awesome. All right. Too cool for school, huh? All right, it's getting late. I burned up most of the day getting what's in your job shop all set, ready to spray down, plastic coat, and then shrink wrap, and it's ready to go. Toolboxes, everything is packed, everything is bolted down to the pallets and everything else. So I have to cut this video short. I'm gonna flip over the platform in here. We're gonna support underneath there. And we have one more piece here. We're gonna go ahead and we're gonna cut another pair of those. And then we're just gonna use the best out of the four. But we wanna test our theory. Reason why we might have had just a little bit of breakout on a couple of those holes was not enough support underneath. All right. Thanks for visiting Job Shop USA. Till next time, get her done.